Hello community! Today we talk about the quantization of large language model. Now if your compute infrastructure at home is looking like this, where you have 8 NVIDIA H100 GPU with 640 gigabytes of GPU memory and about 2 terabyte of system memory, this is not the video you are looking for. However, if this is your PC at home or your laptop, where you maybe do not have an NVIDIA GPU, then we do LLM quantization for reduced memory use. Let's say you want to run any LLM locally on your PC. I have a PC where I have a non-NVIDIA GPU, an AMD GPU, or you want to run your LLMs on your Apple infrastructure, for example on an M1 and an M2, or maybe on the upcoming M3 MacBook. Then this is the video for you. So let's dive into it. Now, in general, we have 3 different ways to do LLM quantization on a professional level. You know QLoRA. This is that I already showed you. Then we have GPT quantization and we have GGUF. Now, what is quantization? Why we need it and how does it reduce our memory footprint? Easy. You know that LLMs have billions of parameters, and storing these parameters as 30-bit floating point numbers requires some significant memory. So quantization can reduce this memory requirement by representing these parameters of our LLMs with fewer bits. So we go from 32-bit to a much lower bit representation. Now, the negative side on this is that the quantization can lead to a degradation in the model performance because we lose mathematical precision of our floating point numbers. And this is here exactly the balance and the quality of the code to reduce here the memory footprint, but try to be as good as possible compared to a 30-bit floating point number representation. So let's start. QLoRA, I have a video about it. I showed you here the research paper. This is clear. GPTQ, I have no video on this. Unbelievable. But you know, it is rather easy. You have a post-training quantization. So this means you have your LLM. This LLM has been done in 32-bit precision, full precision, or floating point 16. So a full-fledged LLM. And then after the training, post-training quantization, you go there and you apply some extreme data compression on the weights of the model. And GPTQ is here specific that it first applies some scalar quantization on the weights, followed by some vector quantization to the residuals. Never mind, simple example. Imagine here an image. You take a photo, it's an image, you have a JPEG format. Now with JPEG you can say that the level of compression you want to have 30%, 50%, 80%. Now the same here. You have a post-training, so the final picture is taken and now you compress it, extreme data compression. This is GPTQ. But the real interesting point, of course, is what is GGUF? Now, it turns out something beautiful. The complete transformer architecture of an LLM, not in Python, not in TF2, not in PyTorch 2, but in C and C++. Amazing work. Everything is in C++. Now, here the main program, of course, is llama.c++. And we have here a specific tensor library that is called GGML. So let's have a look at this. There's one mastermind behind all of this, and now we know what GG means. It means Georgi Gerganov. He is from Sofia, Bulgaria, and he did it. He has here, as you can see, his llama C++ and his GGML. Isn't this unbelievable? So he ported simply the Llama model in C, C++, and he wrote a tensor library for machine learning, GGML machine learning. Let's have a look at this. The main goal of Llama C++, and the original implementation, by the way, was hacked in an evening, was to run the Llama 1 model using a 4-bit integer quantization on an Apple MacBook. So we have here Apple Silicon first-class citizens. We want to have this without any dependencies, and this looks great. Currently supported platform are macOS, Linux, Windows, and Docker. Great. It also runs if you do not have a GPU. So if you have an extreme powerful CPU, it takes a long time, but you can theoretically do it on a CPU, or, and this is the more important thing, if you want, you can offload some of the layers of your transformer architecture specific to the GPU for a faster performance. I will show you an example. So, what are the models here that this methodology supports here? We have the Llama 1 model, we have the Llama 2 model. If Llama 3 will come out, you know it. Falcon, Alpaca, Vicuna, Koala, Wizard LM. These are the models that are currently supported. How complicated is it to code? Not complicated at all. Look, you obtain here the original Llama model weights and place them here in the model directory. Great. You install here your dependencies with requirement.txt. You convert here the 7 billion model to a GGML floating point 16 format with convert.py. Done. Even for a model that use here the byte per encoding tokenizer, you take care about this. Done. Then you quantize the model to 4 bits using here a very specific quantization method. I will show you in a minute. So you say quantize model 7b, GGM model floating 16 to a quantized 4-bit model. Done. Run the inference. This is the complete code if you git clone here the repo. Great. Now, if you want to see the original code, here you see llama.c++, and here you have the code 6406 lines in C++. As I told you, hand in hand with Llama C++ goes here the tensor library for machine learning. This is in C, GG machine learning. It is written in Z, has a 16-bit float support, but also supports here the integer quantization from 8-bit to lower. It has some beautiful optimizer, and it is primarily optimized for Apple Silicon. This is it, ladies and gentlemen. Beautiful. See here the distribution of languages. Great. Yeah, if you want to see, of course, the ggml.c file here, you have 20,795 lines of code. Please make a deep dive. Now, interestingly, as I told you, with GPTQ, we have a very specific post-model quantization. Here we also have a quantization, but a different quantization. So you see here the different models, and you see here a measure, a metric for the quality. And here as a benchmark, we have floating 16, and then we have different quantization methodologies applied to this. You can see here, for example, for a 7B model, the file size, or you go here for 13B model. So you can get an idea where you want to go or which quantization method you have to choose for your particular compute infrastructure. If you like to have a more interesting explanation here of GTML, this is here the GitHub repo Rustformers. They explain very nice the LLMs here. GGML is a C library for machine learning. Yes, 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 for the quantization. And they tell you that the GGML files consist of binary encoded data laid out in a very specific format. You know this now, hyperparameters, and GGML is bleeding edge technology and undergoes frequent changes. You can see this here because with end of August 2023, GGML is not anymore supported with Llama.cpp, C++. Now we have the new format if you want, GGUF. Beautiful. They are always update, newer version. You have some vocabulary scoring. You have here a specific enhancement of the performance through memory mapping. So good idea. Always check back for the latest version. As I told you, the latest version here, we go now to Hugging Face, to the block. I will show you in a second. And the block tells us that new method here for GGML types are available. And here I have shown you 1, 2, 3, 4, 5, and 6 different types of quantization, from a 2-bit quantization to an 8-bit quantization, depending on your hardware infrastructure, depending on the money you want to spend. This is, you choose one of those here. Great. As I told you, the block, excellent account. Go to Hugging Face, the block. As you can see, Tom Jobbins is specialized here in LLM quantization. He has quantized more than 1,000 LLM models. And you can see here on his Hugging Face account, you have here, for example, the Orca Mini model with 70 billion trainable parameter in a GPTQ quantization, or you have the same model, for example, just 5 minutes ago uploaded in a GGUF, and you see GGUF, the new format, but of course, 1 hour ago, we still have the GGML. So this is, if you're interested in LLM quantization, the block is a place to go to and to download the models. Of course, Tom has his own GitHub where you have, for example, text-generation-webui. I'm going to talk about this in a minute. Llama C++, AutoGPTQ, going to talk about this. Great. So here we have it. LLM quantization for our goal for reduced memory use on our computer infrastructure. You want to run this locally on your PC or on your M1 to M3 MacBook. Great. Now, as you can see, those 2 core elements are essential. And around those 2 core elements, people build a wrapper around. So you can download this to your local machine, or you have maybe pointers to the Hugging Face libraries, whatever version, but you have a lot of web UIs. For example, either you go with Streamlit or you go with Gradio, like you have seen in Hugging Face spaces. You can create now an interactive web to share this with your friends who can try out the demos in their web browser. So we built now a web UI where we have those 2 core elements. It's always those 2 core elements, just the wrapper is different and you have a lot of different names, very beautiful names. So I want to show you 8 user interfaces for this specific LLM quantization. Now, in general, what we have, in the simplest case, we have 2 drop-down menus. We have one drop-down where you choose your LLM model, and you have one drop-down where you choose the quantization methodology. With LLM, you have Llama 1, Llama 2, or dozens of other LLMs from the Hugging Face, or you can upload your LLM to the Hugging Face spaces, to the Hugging Face platform, and then you interact with it. Quantization I just explained to you. And the easiest model, the easiest web UI is you run interference, you click here, you enter your sentence, and a specific task is performed here by this LLM that we've chosen in the quantization, and we interact here with a web user interface. Again, you can download this wrapper to your local PC, so whenever you see here, hey, the new model now available on your local machine, it is always the same method, it is always the same 2 core elements. Or I will show you we can upload this to any cloud compute platform. I will show you this on AWS. Great. Now, this was the simplest case. Let's go a little bit more advanced. We have now two additional elements, drop-down elements in our user interface. We can now choose a dataset. Either we have here from dataset, from Hugging Face a dataset, they have more than 400,000 datasets, I think, right now. Or you upload your specific corporate private dataset and you choose a compute configuration. Whatever this might be, 8 times an A100 or 4 times an H100, this is now the advanced version where you get your private machine, your enterprise version of your LLM model behind a very high cybersecurity. These are now secured LLM model only for you with your corporate dataset. And you can fine-tune this here in the cloud on a web UI. You do not need to code not one line of code. This is it. I will show you how it works. Great. I call these things, if you want, auto machine learning, automatic machine learning, because everything is done for you. The optimization for multi-GPU optimization is done by Google, by AWS, by Microsoft to an extent that really professionals optimize this, that you as a normal coder will never reach this level of optimization. So AutoML definitely is a way to go. I will recommend here 3 specific cloud-based versions. The first one is Google Vertex AI, the Model Garden. In this Model Garden, you have the models by Google, you have models that are open source, or you can upload your own LLM model to this specific garden, and then you can run it there in the cloud with the Google infrastructure. Either you go TPU or you go NVIDIA H100, up to you, depends on your credit card. Second option is Hugging Face. Hugging Face is always a good location to check it out. They have an auto train facility over there. I think they support all 3 big cloud infrastructure provider, from AWS to Google, but you choose on which platform you want this. This is huggingface.co auto train. This is simple as can be, and this is now a secret tip, H2O, the wave. H2O.ai is a platform on an AI cloud. You can build your own LLM app immediately in the cloud without any coding experience. Isn't this beautiful? But this is here the complicated version, the professional version where you have your data set, your compute configuration. But there's also the option to have a simple wrapper, a simple large language model user interface, especially designed here for our LLM quantization. So for our Apple laptops or for our maybe not so powerful gaming NVIDIA GPUs 4090 and up. Here we have now optimized for GPTQ and our GGUF. As I told you, our core elements. It's always these 2 core elements. The rest is just a wrapper. Now, let me show you here now the next 5. I already have shown you 3 and now 5. And in total, we have 8 user interfaces. Cobalt C++. What is it? Easy to use text generation software for the GGML models. Single container looks like this. This is the GitHub link. This is now the first here for specific GGUF. Second, you might notice a specific Gradio web user interface for LLM. It supports the normal transformer by Hugging Face. It supports here GPTQ. It supports here the Llama C++ with the GGML and GGUF. This is here, you notice in the name of text generation web user interface, a simple Gradio implementation from these 2 core elements I just showed you. Number 3 is something I have not tried out. This is called Lord of Large Language Models, one tool to rule them all. Okay, maybe you give it a look, I don't know. Just tell you this is another option. Or you go here with LM Studio, discover, download and run local LLMs. You see here the Llama models that are supported. what you can do, how the user interface will look like. Great. And option number 5 here is ctransformer, some Python bindings for the transformer models implemented in C, C++, using here the GGML tensor library. Beautiful. So now you have 8 possibilities, 8 different user interfaces, always for the same 2 main core elements. Isn't this great? And I told you, I will show you that you can install this also on AWS, on any cloud platform. So we choose here the text generation web user interface. It's a very simple user interface. And as you can see here, repost AWS, this is the link if you want to check it out yourself. You can install it on an EC2 and AWS for testing different models. It is a radio user interface. And as I told you, you have 2 drop-down menus. The first is the model, the bloke Falcon 4dB instruct, or the bloke Llama 65 billion pre-trainable parameter with GPTQ 3-bit quantization, or you go with a Vicuna model, or you have some LoRa, or you have here download some custom models for 65B, the Llama model, now the Llama 2 model. So you can go there. You can even split here, as I told you, your transformer architecture layer to different GPUs. This is great. Try it out. This is for people who do not know how to code. This is a no-coder application. Of course, you have to pay AWS for the infrastructure, but I think if you have here your dream configuration of a multi-GPU on AWS, yeah, it should be really, really fast to do here this LLM quantization. Great. So there you have it in all its glory, in all its beauty. QLoRA GPT quantization for the post-training quantization, and something completely different, a implementation in C and C++ with llama.cpp and the GGUF tensor library. Of course, if you want here the research paper for GPTQ, this is the research paper who explains here that they still provide some reasonable accuracy, whatever this means, then in detail on your data, on your training data, in this extreme quantization regime. If you want to see here the GitHub repo here, GPTQ, this is the link to go. Code for the paper GPTQ. Yes, beautiful. Have a look there. They have a lot of models, a lot of information. If you're interested in this particular extreme data compression methodology, go there. Of course, there is an AutoGPTQ version, which is an easy-to-use LLM quantization package with some very user-friendly APIs, based, of course, on GPTQ algorithm. Have a look at AutoGPTQ if it makes sense for your task, for your training data set, for your computer infrastructure. And just to mention this to be complete, of course, there's something like exLLama. Maybe you have heard it. This is a standalone Python C++ CUDA implementation of Llama for use with a 4-bit GPTQ weight, designed to be fast and memory efficient on modern GPU. And the developer tells us, hey, I'm developing on 4090 and a 3090 Ti. If you have older GPUs, AutoGPTQ is a better option for these older GPUs. It is a memory efficient rewrite of the Hugging Face transformer implementation of Llama. Okay, so this is it. These are the 3 main, if you want, pillars for LLM quantization. And now, of course, at the end of this video, you'll say, okay, and what quantization should I use now for my particular model? And whenever I get a question, hey, what should I use? Of course, I show you here a benchmark, but today it is just one benchmark on just one benchmark indicator and just from one source. So this is not at all a representational benchmark, but this is all there is, for example. So we have here a direct comparison between the Llama C++, the AutoGPTQ, the exLLama, and the normal Hugging Face transformer perplexity metric. This is now our benchmark. And I've given here you the link. So forget about the first 65B models. Let's look at 4 Llama 30B implementation. The first one is with Llama C++. The second is the traditional transformer, Hugging Face transformer, Llama 30B, load in 4-bit quantization. The third here is exLLama, and the last Llama 30B model in 4-bit quantization is with AutoGPTQ. And here you have the benchmark for the perplexity. So here you have it, 5.21, 5.24, 5.25 for the first 3. So I think there is not a lot of difference. And with AutoGPTQ, there's a little bit of difference. But remember, this is just one benchmark. This is just on one quantification on the perplexity metric. So this is not at all for an evaluation of the complete model. This is just a very specific snapshot for one perplexity. Great. So you see, it is, Llama CPP is excellent. I would say it is on par with the normal Hugging Face transformer implementation in 4-bit. exLLama, if you work here on RTX 4090, 3090 Ti, maybe this is for you the way to go. Or if you have here a very user-friendly interface, AutoGPTQ might be the way for you. This is it, ladies and gentlemen. It was here really a summarization of 3 beautiful quantization methodologies of LLMs. I hope it was informative. I hope you learned something for your specific infrastructure, for your specific task, given your specific data set that you want to fine-tune your LLM on. And it would be great to see you in my next video.